Welcome to section 13.4. Here we're going to look at some of the costs and advantages of home ownership. And so we're going to be specifically looking at mortgages. All right, and so mortgages where you make a monthly payment towards a home, and it covers not only the amount that needs to go to pay off the loan, but also the interest that needs to be collected. And loans are set up in such a way where the bank is capturing much of the interest up front, right? That way, if you pay off the loan early, they've captured a lot of the initial types of interest that should be gotten over the life of the loan. And they do that by using what's called an amortization schedule. So all home loans are what they call amortized. And it's somewhat simple. You're just going to pay interest on what you have out at the time. So if you and I right now take a $200,000 loan in order to buy a place, what's going to happen for that first month is they are going to take, maybe we got it at 3% interest, right, annual. They're going to take the 3% interest and apply it to the 200,000 for the first month. Now, this is 300% annual percentage rate. So what they would do is say, hey, here's 200,000 and we're taking 3% in that first month. And that's how they get the interest that's owed on the loan. And so 200,000 times 0.03 divided by 12 is equal to 500. I'm going to be paying $500. Whatever my payment is, 500 of it is going to go to interest. It's going to go straight to the bank. And then a smaller portion is going to go to pay down the principal. And that's what we're going to watch happen as we go through here. So there's some things that we want to be able to do. So this was just a little bit of background. Right? So these mortgages are set up through an amortization schedule that's constantly applying the interest to the amount added out at the time, and they do it on a monthly basis. And so there's two things that we're going to be finding here. We're going to find the regular monthly payment, and we're also going to find and come up with what they call an amortization schedule. Both of these are showed pretty clearly in the book, and so is a lot of other things, but we're going to just stay focused on these two ideas and some consequences of them. And so let's take a look at calculating a regular monthly payment like we have here. So let me just get us a clean picture here. So here's our first problem, and this problem mirrors problems 1 through 4 as you go through the homework. So this will be an example that will be related to the first 4 problems that you have in the homework. And it says to find the monthly payment needed to amortize principal and interest for a fixed rate mortgage. Use either the regular monthly payment formula or the given table. And the details of the loan are given here. An $85,000 loan, interest rate of 4.5% over 15 years. And so they're just making up numbers. You can get much better interest rates right now as the government wants you to spend your money and not save it. And that's been the case for far too long. But this is where we're at. So we just have to calculate the regular monthly payment. A monthly payment that's not only going to give me, like back in this case, the $500 interest, but also is for that first month, but also is set up to systematically take down that loan to nothing over, in this case, 15 years. And so the regular monthly payment formula is a little bit overwhelming, but it works. R stands for regular monthly payment, just like it did in previous sections. It's P, the amount of the loan, times the interest rate divided by 12, all over 1 minus 12 divided by 12 plus that interest rate, all raised to the 12, and the time in years that that loan is going to be taken out. All right, so for us, if we were to use this formula, we have everything that we need. We know that P is the amount of the loan, so that was an $85,000 loan. The interest rate is 4.5%. Make sure to write that as its real number decimal equivalent by moving that decimal point back twice, divided by 12. On the bottom, 1 minus, and in parentheses, 12 over 12 plus 0.045. And then that is raised to the 12 times 15. So if I were to run this in my calculator, I would type in 85,000 times 0.045 divided by 12 and hit equals. So 85,000 times 0.045 divided by 12. Now I'm going to try to avoid writing that number down. So that number's in my calculator. Now I'm going to hit divide. And when I do that, it kind of removes my answer in my calculator and just says A and S. So it's going to divide that answer by, and I have to use open parentheses correctly. Open parentheses, 1 minus, another open parenthesis, 12 divided by, and then I would highly suggest to do that as 12.045 divided by 12.045. And then we need to close those parentheses like I showed on the screen already. And then we're going to raise to that. That's the symbol on my calculator. Open parentheses. 12 times 15. And close those off. Now that's the closure for this one, so we need one more closure technically to be the big outside one. And when we hit equals, we have our regular monthly payment of $650.24. So this formula always works. It's designed to give us what that regular monthly payment is that will give us the interest in any given month and scale that principal down to 0 over the next 15 years. So that's what we'd have to pay, is $650.24 a month. Now that's how to do it using the formula, which is actually the hardest way. The nicest way is to use the table that they're referring to. So when they say the given table, just want to make sure I have all my formulas here. Okay, so when they say the given table, they are referring to a table that's in the book on page 759. They may have a pull-out section or something. Let me pull it up, and we'll look at this table together. So I took a picture of it. Here's the table. And let's look at it together. This is the multiplier in order for you to come up with your regular monthly payment per $1,000 in mortgage. So I don't know if you see that up here. Let me draw an arrow. I don't know if I can actually. Maybe it won't let me draw on the picture. So I thought I could. So up here it tells us that all of this is for $1,000 per $1,000 mortgage. Now we have $85,000. So we have $85,000. So here we go. We're going to remember what our interest rate was. Our interest rate I think was 4.5%. And I'm sorry I can't draw on this. It's not letting me do that. So our interest rate is 4.5%, and it was over 15 years. So 4.5%, 15 years, it is this number right here, the 7.64993. That's right in the middle of the 4.5 and also the 15. So let's remember that number, 7.64993. Again, you'll have your table opened up right next to you, but I have to leave that. And so another way to getting our regular monthly payment is to take that multiplier, 7.64993, and multiply it by 85, right? That's a $7 for every $1,000 in the loan. There's 85,000, and so I just have to multiply those two, and look what I come up with. $650.24. It's the exact same number, even if I kept those decimals going. So a much cleaner way to come up with that. Well, you're done. That's what the first 4 problems are all about, coming up with that regular monthly payment and walking away. Now that's going to be part of every other question that follows. So the next question is a question that models questions 5 through 7. And it's coming up with an amortization schedule. And this is a little bit lengthy. And so we'll go through it. And they have a really good example number 3 in the book that does the same thing. So let me get in here and erase something really quick. And we'll come here. and it wants us to complete the first month of an amortization schedule for a fixed rate mortgage. So the reason why they're only going to ask for 1 or 2 months is because it's a lengthy process to come up with that. And so what an amortization schedule does is says, okay, let's talk about your loan. Your loan is $90,000, and the first time you pay it, month one, you're going to have your regular monthly payment. And part of that month one, let me set up a table here that would be a little bit better to understand. So part of that month, there's going to be interest that's paid. A portion of our payment is going to be interest. The other is going to be what is applied to the principal of the loan. It's going to pay down that $90,000. And then we'll have a balance going into the next month. A balance of principal is what those usually say. A balance of principal. It's a great way to compare mortgages. They have to provide an amortization schedule for you. And essentially, this is a 20-year loan, right? So this is payment number 1, payment number 2. There's going to be a bunch of payments, right? There's going to be 20 times 12 payments. It's going to stop at 240, right? So these are the individual months. So for the next 240 months, we're paying off this loan. And so they want us to do the first month. They want to know how much of our payment is interest, how much is principal, and how much is the balance of principal. Well, before I can even do that, I first have to decide what the regular monthly payment is. So we have a $90,000 loan at a 6% interest rate for 20 years. So let's focus on the 6% for 20 years. And let's come here. Let's find 6% and trace that over to 20 years. And we see a multiplier of 7.16431. I don't know if you can see that in there, but a 7 at the 6% interest rate, 20 years, 7.16431. Let's remember that number. So our regular monthly payment is 7.16431 times the number of thousands that we're taking in our loan. There's 90,000. And when we multiply those together, we get a regular monthly payment of $644.79. Now, the homework question may ask for that, but that's not typically part of an amortization schedule. So we have $644.79 that we're paying every month. So in month number 1, we need to figure out what the interest is for the month. Okay, so let me bring this down a little bit and write some steps in here. So as each month that we have to do this, and I don't think they're asking for any more than 1 month. Sorry, it's not letting me bring that down. So the interest earned for that first month. Remember, as we go into the first month, we have $90,000 out. Our interest rate is 6%, but not all 6% is being applied because it's only the first month. So I'm going to divide that by 12. When we take 90,000, multiply by 0.06, and divide by 12, we actually get a very nice number, $450. So $450 of our $644 payment is going to interest. Well, then how much is going to principal? So step 1 is to figure out what's going to interest. Let me see now if I can move that down. Not sure why that's not letting me move that down. There it goes. So step 2 is to figure out how much is going to principal. Well, how much is going to principal was the old amount, 90,000. Well, actually, that's not true. How much is going to principal is our payment amount. We were wondering how much of our 644 is going to that. It's the amount of the regular monthly payment minus what went to interest this month. So now we're going to take our 644 and we're going to subtract away 644.79 and subtract away 450, and we're going to realize that in our $644 payment, only $194.79 is going to principal that month. So we can think that, oh my goodness, I'm doing much better than renting this month because, instead of paying that to my landlord, I'm putting that towards my house. Well, technically, you're only putting $200 about of your $644.79 to the house itself. It is definitely better over the long haul to buy. Um, but for a short-term thing, it may be better to rent. So $194.79 is what the principal is. That means the balance of the principal. That's the last thing. Step 3 is to find out the balance owed. Well, we did owe $90,000, and we were able to put in $194.79, and so now the balance owed is only $89,805.21, and that's our guy, $89,805.21. So as I go to do the second month, and I know this one's not asking for it, but as I go to do the second month, I need to redo steps 1, 2, and 3 with new numbers. So let me come in here and show you what those new numbers would be. Instead of 90,000, we're going to go into that second month with only 89,805.21 owed. And so the amount going to interest is going to change. So it's 89,805.21 times 0.06 divided by 12. And we're going to get, instead of 450, we're going to have 449.02. Or actually 03. So 449.03 goes to interest there. And so now the amount going to principal is a little bit more, 449.03, and now we subtract off that from the stagnant 644.79. That's a consistent monthly payment that you're going to pay. 644.79 minus 449.03, and we come up with $195.76. So you can see the amount you're going to pay to principal is slowly going to increase, and the amount that you're paying to interest is slowly going to decrease. But you can see what I was saying. Much of the interest is going to be captured up front. You'll reach a tipping point when the principal starts to overtake the interest, and that's really nice when that happens. So what's the balance now? Well, the balance isn't 90,000 minus 194.79. Those both have changed. So the balance is, well, it was 89,805.21 coming into the month, but we just paid $195.76 to it. So if I subtract those two, I get 89,609.45 is what's owed now. $89,609. Sorry, I remembered that wrong. 45. And that's how you do an amortization schedule. It's going to be the longest thing that you do in this homework. There are 3 problems that deal with that, 5, 6, and 7. And so it gets long if they ask you to do more than 1 month. They'll never ask you to do more than 2. I can promise you that. The next group of problems come from, it spans about 3 problems in there, 8, 9, 10, I believe, as we go in there. And this one's not so bad. Let me expand this a little bit. Find the total monthly payment, including taxes and insurance, for the following situation. So this one's going to be really fast, relatively fast at least, because much of the information that we need is given. So we have a mortgage of $71,500 that has a 4% interest rate, and the term is 10 years. The annual taxes is 509 and the annual insurance is 333. And the question is, what are you going to have to pay per month if you pay as a lump sum your mortgage payment, your taxes, and in your insurance, which is very common for people to do, is to pay all of those at the same time and have what they call an impound account as they pull off what's owed for taxes and insurance and then pay those companies or that government themselves. So how do we do that? Well, the first thing we need to do is figure out our regularly monthly payment. So we know it's going to be some multiplier that we pull out of the chart per thousand. This is going to be 71.5 thousands, right? 71,500 is 71.5 thousand. So we're going to figure out what our multiplier is by looking it up. We're going to note 4% for 10 years, and we're going to come to this chart. 4% for 10 years, we're using this big multiplier of 10.12451 that's there at the 4% 10 intersection. Okay, so let's remember that 10.12451. Again, you won't have to, you can just write it down because 10.12451. Let me erase that, make that look a little bit better. 10.12451 times 71.5. And so when I multiply those two together, I get 723.90. So my regular monthly payment is $723.90. I'm going to need to pay that in order to pay down my mortgage. Then I have insurance. But it's insurance every month. Right now, the insurance is $333. I'm going to split that up every 12 months, or to figure out the monthly one. $27.75 is what comes out there. And then I also have my taxes. Right? Sorry, I did it a little bit out of order between how the information was given. I only owe $509 a year for taxes, so every month that means I owe, this one didn't come out as smoothly, but it rounds to $42.42. So we're going to take in order to find out what we owe per month, including mortgage, interest, and taxes, I simply just add them. So I take my $723.90, add the $27.75, and add the $42.42 to get a grand total of $794.07. If I pay that every month, I'm paying my taxes, my insurance, and my regular payment for my home. The last thing that we want to have you look at is how much interest a bank gets over the years, right? So it's actually staggering. And so anything you can do, so if you have a mortgage payment, a lot of people would suggest making an extra payment every year if you can afford to do so, and you could stagger that in, but that payment is entirely going to principal, that extra payment, and so it really brings down the amount of interest that you owe, including the amount of time you'll have to pay the loan as well. It's pretty dramatic. But let's just look at what a regular loan would take. This one's more realistic, a $267,000 loan at a 4% interest rate. Now they came up with this 267 because we're purchasing a home worth $324,000 and we have a down payment that's required and we pay it of $57,000. So all we owe is $267,000 on the home. That's what we're actually taking the mortgage out for. 4% for 25 years. And so we're back to question number one. Hey, what's my monthly payment? So one of the first things they're asking for is the monthly payment. Well, that monthly payment, I'm not going to be able to write in that box, by the way. Oh, I could type in there. That monthly payment, we know how to get that. That monthly payment is what they call R. It's 267, the number of thousands, times the multiplier. The multiplier is going to come from 4 and 25 years. So 4%, 25 years. Let's get that a little bit smaller here. And if we travel over in the 4% row to 25, we see a 5.27837 number. So 5.27837. Let's go back here and do that. 5.27837. And when you multiply those two numbers, we find out our regular monthly payment is $1,409.32. Okay. So that's going to be the answer for that guy right there in the monthly payment. So now let's total. How much are we going to pay over the life of the loan? So the total paid. Well, we just found out that we're paying $1,409.32 every month for 25 years. Now, if I just did that, that would be only 25 months. But this is 25 years, each year having 12 months. So we're going to take the 1,409.32, multiply by 12 to know how much we paid every year, multiply by 25 knowing that it's going to go on for the next 25 years. And when we put all those together, I'm getting 422,796. So remember, we borrowed 267,000, but yet we're paying the bank $422,796. So how much interest did they capture over the life of the loan? The total interest captured is simply taking what you paid them minus what they gave you. Remember, they only gave you 267,000. I say only. We didn't have it. That's why we're doing this. So we take the 422,796, subtract away the 267,000, and we get a whopping $155,796 in interest. That number gets bigger if you extend the life of the loan. Like if we did a 4% interest for 30 years, it would be even bigger than 155,000. If we shorten the term of the loan, then it gets smaller. And like the best thing that we can do is make extra payments to pay down that principal so it just goes to zero quicker. Because remember, that interest is always applied every month on the outstanding balance. So if you're able to bring that lower, it'll definitely help. But $155,000, 155,796 in interest gotten by the bank. Pretty awesome if you're a banker. Not so great if you're a homeowner, but that's the price of home ownership, right? That you would pay that in order to get that 267,000 now, so you could have that home that you want. So this should guide you through all of the 13.4. Yeah, I'm remembering the section number right. 13.4 homework. Yep.